Okay. All right, so weekly planning meeting for chapter one.
Chapter 1, yep.
Chapter one for the traits. So we just want to take a moment to look at the student tracker for Amplify, and that's all updated and input into the tracker?
Yes.
Okay, cool. Were there any highlights for the or the Amplify assessment?
Well, I actually had,
I know it's the pre-assessment. There's not
right,
much
the
to really look
pre-assessment,
at.
but there were a couple of kids who scored a 2 on it already.
Wow.
Not a lot, but
Which cohorts was there?
D and E.
E.
Mhm.
Scored 2.
Yep,
Wow.
and Bowie.
Cool.
Yep.
So I don't see the pair in there though. Your
No.
pair assessment is coming
This
up
week.
this week.
Yes.
Okay. Yep. So this lesson that we're planning here is to prepare students for that pair assessment.
Correct.
Gotcha. Okay. Cool. So after that pair assessment, we can come back and meet and look at data trends from Amplify to pair.
Yes.
Okay. Cool. So let's take a look at the lesson that we're planning for later this week. I do love what you put together here though, and your intentional focus around the key concepts. How it's
Trying.
right there on top
Mhm.
and it's addressed throughout. I really like that. I did have some comments and questions though, so
Okay.
we'll just jump right into it here. So for the key concepts for this lesson, which key concepts are we covering?
The differences in the structure of protein molecules and how they connect to affect other protein molecules.
Okay, so
this
the
is like
structure
how they get the
and how they
different structures.
connect,
Mm-hmm.
and it results in different traits. So
Yes.
that's 1.4.
Yes,
Okay.
which is a hard concept for them.
So for this lesson, how do they get started?
I just have them go into the sim.
Okay, yeah, let's pull up the sim.
Yep. And so I used, in this one, I wanted to, even though they talk about flexibility, I wanted them to go into bristles only because Greg has visibly no bristles. So they can see how the kids, like I played with it, and then I wanted to see how the offspring would look. And it would be good to see how many of them will predict and why. So what I did is just have them click on the spider and just look in the protein molecules themselves. And what do they notice is happening between Greg's that has no bristles and compare it to like Zora, who has dense bristles, which is a lot of bristles.
Gotcha, okay. So in the observations, though, that we're doing here, is there anything, what is their task? What are they looking for specifically?
So they would just, what they should notice is that the protein molecule that's being, and they have to use the vocabulary words, ribosome,
Right.
That's being created in the ribosome are connecting to the other protein that exists there and going into the nucleus. And then
Okay.
I'll ask them, so if it goes into the nucleus, what is the nucleus? And they're supposed to know that. It's the brain of the cell, which is going to give her that trait.
So is there any way we can direct them, or any language we can provide that will get them to focus on the language that's in the key concept, so the structure of the protein?
Yep. So what I did was I printed, I forgot to have that ready, a list of vocabulary words so that when they're writing their response to what they're noticed, they have to use the vocabulary terms to make sense of what's going on. Instead of telling me, because a lot of them when they write, they would write, it goes here and they do this.
Right, naming what it is.
Right.
So I'm just wondering here that it says, what do you notice? What do we want them specifically to notice though?
That the
Or
proteins connect. So if you look here, you can visibly, they're gonna write down, oh, I see, and they have the example and label what each key
Right.
term, they already did that and know that. So now they're gonna see, now that we're really going in, they're gonna say, oh, well, this pink one is going to this dark pink one, which is what I don't want them to say. well, what is that pink one called? And then they have to say the protein gene
Got it.
for that molecule, and then the dark red is the proteins already in the cell. But if they look at this, if they look at Greg, what they're gonna notice is that they just float around.
None of them are connecting.
None of them are connecting and none of them are going to the nucleus.
So my own wonder as a student then is, are they not connecting because the structure is so different that they don't connect?
Yes.
So how can we get them to stamp that it's the structure is the reason why they're not connecting?
So the share out, they're gonna do a turn and talk, and what so they're gonna have their own individual time, their quiet time, their think time, to develop whatever it is they notice. And then they're gonna turn and talk, and they're gonna share, and hopefully they'll come up with, oh my gosh, that's the reason why. They need to have that connection in order to have hair.
Okay, I like that.
So we call Gray bald.
Bald.
He's bald.
Bald.
So he's bald.
Okay, so it's not so much providing the language during the observation. It's
I
letting
want
them
them to discover
explore it,
Right.
and then during the share out
Right.
is when you're going to get them to stamp.
Right,
that
and
it's
then
the
I'm
structure.
gonna try to pull that no matter what, and I'm gonna connect it to humans, right?
Yep.
So no matter what cream you use on your hair, if you don't have that chromosome to make a full head of hair, no cream is gonna
It's not
help
gonna-
you
right.
because
They
it
can't
doesn't connect.
Yep, I like that. Very good. So in here though,
Mm-hmm.
is there somewhere just real short that they can stamp that alone? They will not connect because the structures are different. Just real short and simple.
So what would you like me to?
So it says, your next question is, what differences do you observe in the bristle traits among spiders?
Right, and so that I'm just guiding them into what we just talked about. So that's just the guide, and once they do the two, what do they notice is the big takeaway, the big difference,
So I wonder if we can break down that question a little bit and
without giving it to them.
ask them, why do some connect and why don't some connect?
But if I tell them that, then they'll know. They have to discover. I want them to discover in order for you to have. So when they look at the traits, some say dense, some say sparse.
Right.
So we just explored the two extremes, the none and the dense. And then later we'll go to the sparse. And then in the next page, oh no, this next page goes to, but when they go to, I guess, what was stamp? I don't want to give it away though.
So what would giving it away look like?
Giving it away would tell them that they will have to connect.
So they make that determination up here, though, right?
They make the determination after this.
So they have their observations, they share out, and then after this, they make that determination.
Yes.
So then a stamp, I guess, after that.
Right.
Yes. Okay.
And then I will go into that example that I told you about the no cream.
Yep.
I said, well, what happens when people go bald? Can they just eat more protein or put a hair cream to make that hair follicle come back?
Yeah. What's the root cause of
Right,
it?
right. And then it really comes down to your genes.
So in a one sentence statement,
Okay.
what could they say?
That will let me know that they understand.
Yep. That way you could even just do a quick walk around and see one quick sentence that would tell you they got it or they don't.
Just exactly that. If they don't have the R1, and I want them to say this, I want them to notice that, my bifocals, that Zora has R1, so she's strong, she's dense.
Yep.
Greg has R2, he has none.
And they've done the R1, R2 before.
Right,
They had that
right.
language. Yes.
That's when we explored, when
Yeah.
we were exploring the seminar, other papers. So the big takeaway I want them to understand, if they don't have this R2 trait, their protein molecule will never connect to have hair.
So the only thing I want to push that though, so in the key concept, it's the structure of the protein. How can we get them to use that word, structure of the protein?
Okay, I see what you're saying. Okay. So after they do this, then I would provide, okay, so let's take what you said and let's rewrite this as a scientific statement. And then
Yeah, that's
we would use the vocabulary words and saying that it depends, because structure is here.
yeah.
So the structure of and then I will help them form it. Would that be okay?
So
If they had the idea, but just helping them just for time's sake.
Yeah, because up to this point, at this point, they know already that they've discussed and you've sort of stamped that they're coming together because of the structure allows it,
Right.
or they don't come together because the structure doesn't allow it.
Right.
I just want to get them to write it and stamp it. So what
Right.
what would the question be in the stamp?
The question would be, I guess I can pose a, what would be a scientific claim that we can write
Mm-hmm.
to say about the protein molecules of bristles?
Where's the so how they connect to other protein molecules?
But because we talked about bristles, that's why I said
Right,
bristles.
right, yeah. So can you say that one more time?
my God.
So what? You say something good and then we forget.
Right.
What would be a scientific claim that would?
What did I just say? What did I just say? What would be a scientific claim that we can write that answers the question, how do protein molecules to connect to create a trait?
How do protein?
How
could protein molecules
connect?
So let's not say connect, 'cause maybe they don't connect, right? So they do connect or don't connect.
How can protein molecules? Well, that's in the key concept. That's why.
How does the structure of protein molecules affect?
But then that's giving them the whole thing, because all they have to do is reword it. Oh well, at this point, we just want them to reword it, because the claim statement would just be the answer to that question.
Right. So what would be a scientific claim that would answer the question, how could protein molecules affect the bristles? Affect which type of bristles?
The trait for bristles.
The trait for bristles. Well, protein molecules. How could
Because
protein
feature
molecules
is the bristles
affect
and the trait is how much they have.
the trait for which bristles a spider will have?
No, well,
just
the
the
trait, but the trait is
For none for that one.
Right,
Yeah.
right.
Okay. Trait for bristles.
right, because the trait will tell if it's none, sparse, or dense
Cool. Okay. So we'll add that in as the stamp after
after this. one.
this.
Okay.
Yeah. Awesome. All right.
So that's the part one to get to the key concept. And
Yep.
then what they're going to do is choose those same spiders. And then they're going to predict first what will their children look like, or offspring. I want them to use offspring. So
I like this here, that how you have the metacognitive piece down here where now they're explaining why their prediction was or
right or wrong.
right or wrong. Yeah,
Yes.
I like that.
So if they do, so what I'm going to show them is what happens. So I want to show them the separation of, so he has R2, R2, and R1, R1. So then I'm going to bring in math and I'm going to ask them about probability. So if they mix together, what's the probability of the offspring having the bristle feature, whether it'll be none, sparse, or dense?
I like that. Yeah.
Using, and it's random.
How are you going to introduce probability? Are they going to know what that is? Did they learn that already?
Heck yeah, they should have learned that in 4th, 5th grade.
I hope.
So I mean, I could ask them what's probability.
And just have some sort of example ready if they need
Okay.
to know about
They
probability.
better, and I'm gonna tell them. I'm gonna tell Mr. Sinek you don't know about probability. But yeah, so I guess rolling a dice.
Yeah, that'd be a perfect example. Yep.
So roll the dice. What's the probability that I will roll a 5?
1 in 6, right?
Right.
Yeah.
Right.
Like that's
So,
perfect. Yeah.
And then go into this. Well, we have 6 here, 6 here. What's the probability of this offspring? I'm gonna say only because once they get an R1 in the answer, it'll definitely be either sparse. It'll be sparse. It won't be none.
Right.
Because Zora doesn't have an R2.
Right.
So that's what I want them to see is these genes, and then this is going to go into, and this is where I'm going to explain about the homozygous and the heterozygous.
So I wonder then after their sketch, what are they sketching exactly? Because there's a whole bunch up here.
So it's not until after they fertilize.
Oh, I see. That's before they come up.
Yes.
Gotcha.
Yep.
Okay.
Yep.
Gotcha.
So
Yep.
so not this part, but the part where when they randomly fertilize, the probability of them when they mix together. What does that look like?
Okay. So what traits will their offspring inherit?
Because I want them to use vocabulary.
So the question is, so it's why the offspring displayed those traits, which is part of the key concept, and the role of the proteins in determining those traits.
Right. Which
is
is
the key
this,
concept,
which
yeah.
is the sketch. So they should see R2R1, 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 R2R1. And that's because both parents were homozygous.
Yeah.
And so the extend before they, after they finish this, then I want them to see what happens if you have 2 heterozygous parents. Then that probability will break down even more.
I like it.
But their focus has to be here, not necessarily. This is what I learned from last year, because last year I just had them look at the trait and wasn't understanding why are they not getting. Like some of them will get it, some of them, but if they really focused on the actual gene itself,
Right.
then it will help them to understand, hoping that it will help them to understand.
So the last piece that I guess I have for this is from this observation and analysis, how do they go from this, how do you know that they have what they need to answer the exit ticket, going from this to this?
So then they should be
I guess
able
what's your check for understanding in between?
Right. So my check for understanding, after we do this and they understand, okay, they got, it's one R1 from here, one R2 from there. This is very basic. But then when we go to, this is how I'm going to know if they understand. So if I go to, let's even say, so Leo is heterozygous and Ruby is heterozygous.
Yep.
So if I put them together, what's the chance now of what the offspring will look like? What gene will they inherit? And that's the harder question. Right. And the reason why is because now you have 2 types of traits that are, so now you have 4 traits that are separated in each sperm and egg. And then with their offspring, what can you say about the probability of them inheriting a gene? And what they should be able to tell me, it can be random, like, so this F2 and this F2 can go together and then the offspring can be homozygous again.
So that's going to be wrapped up in your check for understanding?
Right.
So what would that question or task look like then for that check for understanding? Because they're going from this, I know you're having a discussion, but is there like a scripted question that kind of puts all that together?
Right, I do. And I think it would be this part of the question. What conclusion can you draw about the role of proteins in determining the traits in living organisms?
And you're seeing the
Right.
role of the proteins actually coming.
Right.
Yes, that's it. Right. So if they can answer that in that one sentence,
Right.
then they're ready to move on to the
Right.
full thing. Yep. Cool. And then you already had the pair assessment prepared,
Yes.
can we just look at the alignment between this exit ticket
Yep.
and the written response for the pair assessment? Just to see that it still addresses or assesses that key concept?
Test. Let me go into my test. How do I go to my test again?
It looks so different on mine.
Oh,
Because it's all shared with me. It's
dashboard.
not that I created.
Okay. So dashboard. How can I see the test? I did the test, but I assigned it, but I'm trying to see if I can see the test. Okay, let me just pull it up. Okay, so I guess I go to question. I can't see the questions yet because they didn't start it. How do I see the test? Standard base. I forgot.
Should be a way to like open it up and at least edit the
Right.
question or something, right?
Library, item bank test. Is it in my test? Oh, and then I created by me.
There you
Duh.
go. Yeah, that's it.
Okay, here we go. Traits and review. So this is the question that I have to see if they understood. Here it is. Question number 3. So crawfish are shelled organisms that live in shallow freshwater rivers. They can have an antenna of different lengths. 2 parents with medium length antenna have offspring.
Mm-hmm.
One of their offspring has short antenna and one has a long antenna. How did the offspring end up with traits that are different from the traits of their parents? How did the gene combinations result in these traits? So they should then be able to visualize, okay, if they have heterozygous genes in the random fertilization, they can inherit the genes passed down that is in their DNA that the parents don't have, but the offspring could have.
Yeah. So it's the same concept as the
Right.
spiders, right? So what?
Right.
Long bristles and short bristles,
Right.
or whatever, but long
Now,
antennas, short
antennas,
antennas.
right.
Yep. Same exact concept.
Mm-hmm.
I like it. Yeah. So it's taking the same key concept, just applying it to a different animal.
Different animal.
Yeah.
Mm-hmm.
Cool.
It's on prey.
Hey. Cool. So just wrapping it up then, one specific instructional adjustment that we are making on this upcoming lesson.
So I'm going to create a stamp question.
Yep.
And for here to make sure that they understand the takeaway.
Yep.
And reforming it knowing that it's the structure of the protein molecules.
And I wrote it down here too, so I'll
Okay.
send that to you that way.
Yes,
You
because
got
I'll
it.
forget.
And during what part of this lesson then are you going to aggressively monitor?
It'll be 2 times. The first time will be here where they are first looking at the homozygous spiders.
Yep.
And then again when they are making the offspring.
Yep. So the 2 checks for understanding
Right.
doing the aggressive
Mhm.
monitoring. And the mastery, evidence for student mastery is going to be what for this lesson?
For the exit
The
ticket.
exit ticket.
Mm-hmm.
And that'll
There-
tell you
that'll
whether
be
they're
at
ready
the end of
for the
class.
pair assessment or not
Right.
too. Awesome. Cool. Any questions for me?
Time.
I wish we had enough of it.
Right, time. The only problem, I think, in getting this done for every single key concept is time.
It is. It's tough. But
And
I
then
like what you did though too. The homozygous and heterozygous is a future key concept, but you're pulling it into
They
this where it
have
makes
to.
sense, or we won't have
Right.
time for it.
Right. But it won't make sense. Then they'll tell me they and it. And
Exactly.
that's why I have this sheet. Do not say they, do not say it. What
What
is
is
they and what is it? And I think that'll help me now that, that take that vocabulary sheet out every single class.
Sounds good.
Don't tell me child. Tell me what? Offspring.
What is it? Yeah.
Right.
And then you'll have these student work samples. Then we can take a look at
Mhm.
later in the week.
Yes.
And then also by the end of the week they'll have pair assessment
Yep.
done as well.
Yep.
Awesome.
And then when we come back, I'm going to give them a review, a practice, what do you call that? the first test,
Oh, the pre-assessment.
pre-assessment over the break, and then the science fair stuff. And that's gonna be their break. And then when we come back,
The
we
winter
should
break
have-
packet or, yeah.
1.5 weeks, and then critical juncture.
Yeah, sounds good. Thank you, Braxton.
You're welcome.
Well, that helped me out a lot. Thank you. And this is cohort, this was D, the one that you just
Yes,
finished.
and F did better than D.
Wow. What kind of kids came in? Where'd they come from?
Right, but it wasn't even them. Like Rashid is really getting into it.
Is he really?
Janice, Deja, Khalil, like they're really getting into it.
They like spiders. I don't
No, and I think also because when I did the strawberry, the opener.
Yeah. Oh, yeah,
That
yeah.
helps.
Where they actually got to see the DNA.
Yes.
Yeah.